to be talking about the first lesson in the unit for Chapter 7. We're going to be talking about trigonometric functions and acute angles. So our two goals for this lesson are to be able to use trig functions to find ratios of sides for right triangles and use these same functions to determine other lengths or a missing angle in a right triangle. So we're going to break this up into two parts. This will be part 1 today. All right, so the essential question is, how can ratios of lengths of sides within right triangles help determine the other lengths and angle measures in the triangles? So we're going to start with talking about trigonometric ratios. So what is that? Trigonometry. Trigonometry is a study of triangles. So we're going to be talking about right triangles in this course. So we're going to be focusing exclusively on these right triangles. And now we have two right triangles before us. So let's look at the one on the left side first. Now, let's say we wanted to find, we're interested in a specific angle in that triangle. This top one right here. You see this 0 with a slash through it in the middle? This is the Greek letter theta. Okay, we're going to be using theta throughout the video, but we can also use x. But we usually, for trig, we usually use Greek letter theta. All right, so what we're going to do is we're going to label the three sides in this right triangle. So if we're interested in this theta angle, the side that is opposite of that angle is called the opposite side. Okay, so we'll call that opposite. We're going to use O for short. Now this is the side that is directly across the angle of interest. Now the side that is next to the angle of interest is called the adjacent side. And we'll use capital A for that. Now the side that is the longest side, so the adjacent side is the side next to the angle, but is the shorter side. The side next to it, but also is the longest side, is the hypotenuse in this example. You guys may remember that term from geometry, hypotenuse. All right, so the hypotenuse is the longest side in the triangle. The adjacent is next to the angle, but is the shorter side. And the opposite side is directly across from the angle. All right, so for the second triangle, we're interested in this angle on the bottom right. We call that theta as well. So in this case, the side that is directly across is opposite. The side that is next to it is the adjacent side, but is the shorter side. And the hypotenuse is the longest side in the triangle. All right, so now we know, hopefully you know how to identify opposite, adjacent, hypotenuse. So now we're going to talk about the 6 trig functions, the 6 trig ratios. Okay, so the first 3 trig functions are sine, cosine, and tangent. So the sine, we use sin for short, and so we don't call it sin of theta, we call it sine of theta, and that is opposite over hypotenuse. So using this right triangle, opposite over hypotenuse. And then cosine, cos for short. So cosine of theta is adjacent over hypotenuse. And then tangent theta, we use tan for short, is O over A. So to remember these 3 trig functions, use the acronym SOHCAHTOA. So the sine, the S in SOHCAHTOA stands for sine. And we have sine is opposite over hypotenuse. So that's, this part right here, opposite over hypotenuse. And then we have the C in cos in SOHCAHTOA, stands for adjacent over hypotenuse. So I'll circle that. That's this part right here. And then the tangent is the T and O over A for opposite over adjacent. So I'll go ahead and use another symbol here. So that's that part. So SOHCAHTOA is going to help you remember what sine, cosine, and tangent are equal to. Now to find the other 3, we're going to do the reciprocal or flip the fraction to get the other ones. So for cosecant, secant, and cotangent, those are my last 3 trig functions. To get cosecant or CSC, we simply flip the fraction in sine to get the cosecant. To get secant, we flip the cosine fraction. So notice that they're flips of each other. They're reciprocals. And then to get cotangent, we flip the tangent fraction. All right, so that's how you get those 6 trig functions. So let's look at an actual example where we write them down. So we have 2 right triangles given below us, And it says, given the right triangles, write the 6 trig ratios for the given angle of interest. So we're interested in this top angle. We call that theta. Let's go ahead and label our sides. This side right here directly across is my opposite side. This side directly next to the angle, but the shorter side, is adjacent. And the longest side is h. Now we don't know what h is. We got to find it. Let's go ahead and label part B. We know that h is 7 here. We don't know what the opposite side is, right? The side that is directly across. And then 3 in this case is the adjacent side. So that's how we label the adjacent, hypotenuse, opposite for those two triangles. Next, we're going to find the hypotenuse in part A. So to find the missing side in part A, you're going to use the Pythagoras' theorem. Remember the Pythagorean theorem, probably from geometry? You're going to be using that here. So notice that the C is green. The C corresponds to the H in the diagram above. Okay, the C is always represented by the hypotenuse. Okay, the C is always the hypotenuse. So in this case, we have 3 squared plus 4 squared. Those are the other two sides. It doesn't matter which one's 3, which one's 4. The other two sides go on the left side. And then for the C, that's the hypotenuse side. So you're going to plug in the hypotenuse there. But we don't know what that is. So we'll call it C. Or you can call it H if you want. H squared. All right, so now in this example, we need to do 3 squared plus 4 squared. So 3 squared is 9. 4 squared is 16. So 9 plus 16 is 25. 25 equals c squared. Now we need to take the square root. That's the only way to get rid of the square is with a square root. So now we're going to get square root of 25 is 5. So we know the hypotenuse is 5. So we'll go ahead and label this 5. All right, so now we have all 3 sides in that triangle. So now remember that we're going to be using SOHCAHTOA here to find the sine, cosine, and tangent. So SOHCAHTOA is opposite, so sine is opposite over hypotenuse. So in this case, my opposite is 4, hypotenuse is 5. So we have here 4 over 5. All right, cosine is adjacent over hypotenuse, so that's going to be A is 3, H is 5. Tangent is opposite over adjacent, so O is 4, adjacent is 3. So those are my 3 trig functions. Now I'm going to go ahead and flip them to get the next ones. Okay, so I'm going to do the reciprocal to get those other guys. So I got to flip 4 over 5. That'll give me 5 over 4. That'll give me the cosecant of theta. To get the secant, I flip the second fraction. Cotangent, I flip tangent. So it's going to be 3 over 4. All right, pretty straightforward. So you're going to use Pythagorean theorem to find the missing side, if you do have a missing side, and then use SOHCAHTOA to get the trig ratios. All right, so let's do the second right triangle. So we're missing the opposite side here. We know A, we know C, but we don't know B, right? So we know the hypotenuse is 7, so that's c squared. Remember, the c is hypotenuse. We know a squared, that's 3 squared, but we don't know the other side, so we'll call that b squared. And then now we know that 3 squared is 9, so we get 9 plus b squared equals 49. So now I'm going to solve for b here. To solve for b, I have to subtract the 9 over on both sides. I have b squared equals 40. Now, the only way to get rid of the squared is with a square root. So we're going to do a square root of both sides. So we have b equals square root of 40. Remember that we can actually break the 40 down. We can break the 40 down into 4 and 10. Remember, 4 is 2 times 2. 10 is 2 times 5. So remember that we take each pair and we pull it out of the radical. So the pair goes out of the radical. So now that means that the 2 goes out, and then we don't have any more pairs here, so we're just going to multiply that back in, and that'll give us 10. All right, so square root of 40 is 2 times square root of 10. Just a little review of how to simplify radicals, in case you forgot. All right, so now we need to find the sine, cosine, and tangent. Remember, use SOHCAHTOA. So, S-O-H. So sine is opposite over hypotenuse. Opposite side. The opposite side was All right, so we said the opposite. Let's go ahead and label the sides first. So let's go back to our right triangle. This opposite side we said was 2 square root of 10. Okay, so that's my third side. So we got opposite over hypotenuse. So 2 square root of 10 over 7. So we have 2 square root of 10 over 7, opposite over hypotenuse. Now we need the CA, so CAH. So cosine is adjacent over hypotenuse. Adjacent was 3, so we get 3. Yeah, so it was 3, and then hypotenuse was 7. Tangent is opposite over adjacent. Remember the TOA. So opposite was 2 square root of 10. Adjacent was 3. All right, so we got our 3 trig functions. Now we need to flip those to get the other ones. All right, so if I flip the sign, that's going to give me cosecant. So if I flip this, I get 7 over 2 square root of 10. Now, I need to rationalize this denominator. I can't have that radical in the denominator. So remember that to get rid of the radical in the denominator, I need to multiply by the same radical here. So I need to multiply by square root of 10 on the bottom. But if I do it on the bottom, I have to do it on top as well. Okay, so just a quick reminder of how to rationalize those. So now we get 7 times square root of 10. And then square root of 10 times square root of 10 is square root of 100. Now, square root of 100 is 10. 10 times 10 is 100. So this right here is 10. And then 2 times 10 is 20. So this is going to give me 20. Okay, so I'm just going to write it out as 20. So that's my cosecant. Now my secant, I got to flip cosine. So that's going to be 7 over 3. Done. Now for my cotangent, I need to flip the tangent. So that's going to be 3 over 2 square root of 10. Okay, we got a radical in the denominator, so we have to rationalize it. So I'm going to multiply by the square root of 10, top and bottom. So we have 3 square root of 10 over, and then I'm going to use the same work that I did earlier and just call that 20 because I did that on the top. All right, those are my 3 trig ratios, my 6 trig functions, I mean. All right. So now the next thing we're going to talk about is how to use one trig ratio to find the others. So in this example, example 2, we know what tangent is, and we want to use tangent to find the other ratios. So they tell us that tangent is 15 over 8. Remember that tangent is TOA. Remember TOA, SOHCAHTOA, opposite over adjacent. So this is opposite over adjacent. So what's the opposite side? Opposite side is directly across from the angle of interest, right? So we want to go directly across. So that's 15. Adjacent side is next to it, but the shorter side. And then we got our hypotenuse, which we don't know what that is, but that's fine. We can find it. So we're going to find that hypotenuse using the Pythagorean theorem. So that's going to be 8 squared plus 15 squared equals c squared. 8 squared is 8 times 8, so 64. 15 times 15 is 225. 64 plus 225, we'll just add that together. That's going to be 289. Now we take the square root of 289, and you could do that on the calculator. You're going to get 17. So my hypotenuse is 17. So now we can go ahead and find the 6 trig functions. Remember, sine is I'll go ahead and write it. I'll write out SOHCAHTOA over here. So remember, SOHCAHTOA. So sine is O over H. So O is 15, H is 17. Cosine is A over H. So 8 over 17. Tan is O over A. So 15 over 8. And then to find cosecant, I got to flip sine. So it's 17 over 15. To find secant, I got to flip cosine, 17 over 8. To flip tangent, to find cotangent, I got to flip tangent. So that's 8 over 15. All right, and those are my 6 trig ratios. So that's how you use the information you have. So once they give you one of the trig functions, label it on the triangle, find the missing side, and then use that use all three sides to find all six trig ratios. The last thing we're going to talk about is how to find a missing side or angle. So if you want to find a missing side or angle, you're going to follow the procedure that's shown below. So for part A, this is a missing side problem because we don't know what x is, and x is one of the sides. Okay, we do know the angle is 35 degrees, and we do know one of the sides is 10. Okay, so we're trying to find x here. So if we want to do part A and find what x is, well, first off, label your sides. So we know that this is opposite, which we don't know what that is, which is fine. We know that this is adjacent, and this is hypotenuse. So those are my three sides. Now we're going to use a trig function that has a and h in it. Okay, remember SOHCAHTOA. The only trig function that has an a and an h is the c. SOHCAHTOA. So that's cosine. So cosine is a over h. So we're going to use cosine here. So cosine of 35 degrees, remember our angle of interest here is 35 degrees, equals a is x here, over h, which is h is 10. All right, so now we got our equation, we can solve for x here. Cosine of 35 is just a number that you can plug in the calculator. X you can solve, 10 is just a number. So if we want to solve for x here, we need to multiply by 10 on both sides. Okay, so we have x equals 10 times cosine of 35 degrees. Now, most scientific calculators have cosine, sine, and tangent. So if we want to do cosine, we're gonna use a regular calculator that you can find in your computer. So we're just gonna type in calculator on the computer. All right, and then that'll give us the calculator app, or whatever calculator you have that's present in your base computer. Okay, so went ahead and pulled the calculator. So now for this calculator, make sure that you hit the three grid lines here, and make sure that it's selected to you select scientific. So you make sure that it's a scientific calculator. So you see where it says trigonometry, we have sine, cosine, and tangent there, so we can make our calculations. Okay, so first off, I'm gonna do 35 degrees. So I'm gonna type in 35 for my calculator. I'm gonna hit cosine, and that'll give me cosine of 35. Now I'm gonna take that and I'm gonna times it by 10. And you should get about 8.2. We'll just go ahead and round that to 8.2. So that's my missing side. My missing side is 8.2. And that's it. So now for part B, let's label the sides here. We know, let's see here. There's a typo here because we're supposed to know what this is. This is actually right here. This is 12. Okay, so you're supposed to know what that side is. All right, so here we're trying to find the missing angle. Okay, so in order to find this angle, well, let's label our sides. We know that this is the directly across, so that's opposite. We know that this is the hypotenuse, and the side next to it is adjacent. Okay, so what trig function has O and H in the problem? Well, that's going to be the sine. Sine has O and H. So sine is equal to 5 over 12. Okay, so sine of x equals 5 over 12. That's going to be our equation. So sine of my unknown angle, which we call x, is 5 over 12. Now, in order to solve for sine here, I need to actually do what is called the inverse sine. So the only way to get rid of a trig function is to do the inverse of it. So the inverse of sine is the inverse sine, which is sine with a little -1 power. Okay, it's not really a power, but that's just what it looks like. Okay, so the only way to get rid of this is to do the sine inverse, okay, on both sides. All right, so now these cancel. Now we have x equals sine of inverse. So we can do this on the calculator, and this will give us an angle. So on the calculator that's in the computer, if you have this computer, this type of calculator, or you could type it in on Google, you can find the our inverse sine of 5 divided by 12. But here, I'm going to go to second under trigonometry, and that pulls up the sine inverse. Okay, so I'm going to do 5 divided by 12. I'm going to do that first. And then I'm going to go to this trigonometry and then inverse sine right there. And that gives me an angle. Oops, let me do that again because I clicked it too many times. All right, and that gives me 24.6 degrees. 24.6 degrees. All right, and that's my missing angle. All right, part C is another missing angle problem because we're trying to find this angle on the top. All right, let's label our sides. This is adjacent, which we don't know what that is. This is hypotenuse, and this is opposite. So we know O and H. We know opposite and hypotenuse. So this means that we're going to be using sine again, okay? So we're going to be using sine, which is opposite over hypotenuse. So sine of x equals 8 over 9. All right, now to solve this, we need to do the inverse sine on both sides. Now, if this were a tangent, like let's just say off to the side, if we had tangent of x is 8 over 9, for example, we can easily get rid of tangent by doing the inverse tangent, okay? So you can just use whatever function with the -1, and that'll get rid of it for you, okay? All right, so you can use whatever function with a -1 and then do that on the calculator. So you're not limited to just inverse sine. All right, so now these cancel. So we have x equals inverse sine of 8 over 9. And then that we're going to do that on the calculator. Inverse sine, we get 62.7 degrees. There you go, and that's it. So we found the missing angle, found the missing side. All right, we went over those 3 things. We're going to do part 2 in another class. I hope you learned a few things from this video, and I'll see you in the next one.